Okay, so we're going to switch gears. We've been talking about geometric and exponential functions, and now we're going to talk about polynomial functions. And since this is new, we're going to start with just the basics. So the first thing we need to do is talk about some basic definitions. And the easiest way to define a polynomial, what's going to make the most sense to you, is really to talk about what is not a polynomial, monomial. So notice that mono, if you remember that term before, mono means one. So all of these things have just one term. Or you can think about them as all being like one piece. So 4 is its own piece, x, right? Each one of these, even though negative 4xy has multiple things in it, it's all squished together as one piece or one term. Things that are not monomials, for instance, this 4 plus x, that's not going to be a monomial because it's got two pieces connected by addition, right? It's got a 4 and an x. X minus 1, same issue. So you can't have two pieces. Also, we cannot have negative exponents, so you probably need to write that down. And lastly, this last one, even though it looks like one piece, we can't have that because that is causing the x to the third is on the bottom. So we can't have variables in the bottom of a fraction. All right, so a monomial only has one piece. A binomial has two terms. That would be something like 2x plus 3. A trinomial has three terms. So a trinomial will be something like 2x plus 3y plus 4, right? That has three separate pieces. And then a polynomial, we just use that word poly, if you remember this. Poly means many. So a polynomial just means it's something with many terms. All right, and then the last definition that you need to know for the moment is the degree of a polynomial. And you do need to write this definition down exactly. So the degree of a polynomial is the greatest value of the exponents. All right, the degree is the greatest value of the exponents. So for example, if you have a polynomial that says like 2x to the third y, this is going to have a degree of 4. Think about how many variables there are. There are 3 x's right here and 1 y, so altogether that's 4, a degree of 4. Okay, so in this first example, they're wanting me to classify the polynomial by its degree and the number of terms. So the number of terms is easy. There are two pieces here. So this example is going to have two terms. We technically call that a binomial, but if you just want to say two terms, that's okay. And then the degree, remember we have to look at the exponents or consider how many variables are in each term. So my first term has 2, and my second term has 6. There are 3 x's and 3 y's, and the final degree is the one with the highest. So the degree on this whole polynomial is 6 because that was the higher number. Example B down here has 3 terms because I have 3 pieces. And if I go to check the degree, now remember degree has to do with the number of variables. So on the first term, there's no variables. On the second term, there are 3 variables, 3 n's. The last one, there is 1, and the degree comes from the highest number. So the degree on the whole thing is 3. And then one more definition, or maybe two more. Standard form. When we rewrite things in standard form, we just want to order them from greatest, and we're talking about the degrees, greatest degree, or you can think about it being the greatest exponent, to the least. All right, so for instance, A has 4 terms, and if I look at those 4, the highest exponent I see is this x to the third. So I start with negative 4x to the third, and then the next highest I see is squared, so minus 2x squared. Then I've got just an x, so plus 20x. And then I have something that has no variables, so a 0 degree, so that's plus 1. Notice that now my exponents decrease in order. I have 3 x's, 2 x's, 1 x, and then no variables whatsoever. That is what you call standard form. Now, when we have polynomials, we want to simplify them generally so that it's the simplest thing to look at, because a lot of times they can get lots of pieces going on. So what we're going to do is combine like terms. And remember, like terms mean you have the same variables with the exact same exponents. So on A here, even though they're all y's, even though every single one of these terms, one of these pieces has a y, I only care about the ones that have the exact same exponents. So I have 2 terms that have y to the third, which means I can combine those. And when I combine, I'm adding. So that's -2 plus 2. Well, really, those are going to cancel each other out. That's kind of a weird case, but they do cancel each other out. These other 2 both have y squared. And so this is like saying -8y plus 1, -8y squared plus 1y squared. When we add them, we add the numbers. So -8 plus 1 is -7. But the term or the variables stay the same. So it's going to stay y squared. We're not going to add those. We just add the numbers. All right, let's look at B since it's got a few different letters going on. All right, so notice on B, what we want to do is identify ones that are exactly the same. So here I've got p squared q to the third, which means if I'm going to combine it with anything, I need another p squared q to the third. Even though this next term has a p and a q in it, the exponents are not exactly the same. There's a 5 and a 4, so I can't combine those. So I'm going to combine p squared q to the third. And I'm going to put a number in front of that just to make it easier to count. So this is 1p squared q to the third minus 4p squared q to the third. So 1 minus 4 is -3. And then think about the rest of it as just like a word. You're not going to change anything. So that's just p squared q to the third. And then I'm going to consider my next set. I have p to the fifth, q to the fourth. So I need another p to the fifth, q to the fourth, which I have, p to the fifth, q to the fourth. So I can combine these two. -4 plus 3 is -1. P to the fifth, q to the fourth. And the biggest note that I want you to take here is that when you add, exponents do not change. When you add, exponents do not change. That is like the #1 mistake people are going to make throughout this whole chapter, so make sure you learn that now so you don't make that mistake in the future.